Okay, hi everyone, welcome back to this live stream for Windows Server 2003 administration. So I just want to share my screen. Okay. So start of authority SOA records. The first record in any database file is the start of authority SOA record, which looks like this at INSOA source underscore host contact underscore email serial number refresh underscore time expiration underscore time underscore to underscore live. The SOA defines the general parameters for the DNS zone, including the who authoritative server is for the zone. Table 6.2 lists the attributes stored in the SOA record. So field meaning source host, the host on which the file is maintained. Contact email, the internet email address for the person responsible for this domain's database. Serial number. The version number of this database file increases each time the database file is changed. Refresh time, the elapsed time in seconds that a secondary server will wait between checks to its master server to see if the database file has changed and a zone transfer should be requested. Retry time, the elapsed time in seconds that a secondary server will wait before retrying a failed zone transfer. Expiration time, the elapsed time in seconds that a secondary server will keep trying to download a zone. After this time limit expires, the old zone information will be discarded. Time to live, the elapsed time in seconds that a DNS server is allowed to cache any resource records from this database file. This is the value that is sent out with all query responses from this zone file when the individual resource records don't contain an overriding value. So name server NS records, name server records lists the name servers for a domain. This allows other name servers to look up names in your domain. A zone file may contain more than one name server record. The format in these records is simple: domain at INS name server underscore host. Domain is the name of your domain, and name server host is the FQDN of a name server in that domain. There are a couple of interesting shortcuts that can be used in DNS records, such as the following. In a zone file, the @ symbol represents the root domain of the zone. The IN in the in records stands for internet. Any domain in the database file that is not terminated with a period will have the root domain appended to the end. For example, an entry that just has the name sales will be expanded by adding the root domain to the end, whereas sales.chalice.net won't be expanded. What do these records actually look like? Here's a small sample. At INNS1.chalice.net, at INNSNS2.chalice.net. NS records play a key role in the referral process that you'll be learning about later in the chapter, the host record. A host record, also called an address or an A record, is used to statically associate a host's names to its IP address. The format is pretty simple: host underscore name IN A IP underscore address. Here's an example from our DNS database: Minuteman IN A192.168.0.204, Titan IN A192.168.3.144. The A record ties a host name, which is part, you'll recall, of an FQDN to a specific IP address. This makes them suitable for use when you have devices with statically assigned IP addresses. In that case, you'd create those records manually using the DNS snippet. As it turns out, if you enable DNS, your DHCP server can create these for you. That automatic creation is what enables DNS to work. The pointer record. A-records are probably the most visible component of the DNS database because internet users depend on them to turn FQDNs like www.microsoft.com and www.deltaair.com into IP addresses so that browsers and other components can find them. However, the host record has a lesser known but still important twin, the pointer record. The format of a pointer record looks like the following: owner TTL class PTR targeted underscore domain underscore name. The A record maps a host name to an IP address, and the PTR record does just the opposite. Having both types of records makes it possible to do a reverse lookup, which occur when a resolver asks a DNS server to cough up the FQDN associated with a particular IP address. This is a useful function for, among other things, preventing people with made up or illegal domain names from using services like email or FTP servers. The alias record. Almost every company on the web has a URL of www.companyname.com. This is pretty much standard. However, many, if not most, domains don't actually have a machine named www. Instead, they use DNS alias records, more properly known as canonical name or CNAME entries, which allowed them to use more than one name to point to a single host. The syntax of an alias record looks like the following: alias, IN, CNAME, hostname. Suppose there was a company with a machine whose real A record name was kingkong.intexas.com. The same name records can point to mailintexas.com and ftpintexas.com to that machine. A resolver that queried the company's DNS server for either mail or FTP would actually get the A record for King Kong back. Here's how they created the alias: mail, IN, CNAME, King Kong, FTP, IN, CNAME, King Kong, IN, A, 172.30.1.14. The mail exchange record. The mail exchange MX record tells you which servers can accept mail for this domain, bound for this domain. Each MX record contains two parameters, a priority and a mail server, as shown in the following example: domain IN MX priority, mail server host. Why use MS records as an example? Consider the domain chalice.net. Users in your organization have addresses of some user at chalice.net. To make sure that mail is delivered where you want it to go, to your Exchange server, you'd have two MX records. One points to chalice.net and one points to your ISP's mail server. When someone on the internet tries to send SMTP mail to any user whose address ends in chalice.net, their mail server will look to see if that domain contains an MX record. If it does, the sending server will use the host specified in the MX record to deliver the mail. Attentive readers will notice that we said your domain has two MX records. That's because MX records have preferences attached to them. If multiple MX records exist for a domain, the DNS server uses the mail server with the lowest preference and then tries the other mail servers when the preferred host can't be contacted. For example, the two records you use could look like this: chalice.net INMX100 mail.pair.com, chalice.net INMX10 mail.chalice.net. Service records. Windows Server 2003 depends on some relatively new services like Lightweight Directory Access Protocol, LDAP, and Kerberos. These protocols post-date the DNS system by quite a while. Normally, clients use DNS to find the IP address of machine whose name they already know. Microsoft wanted to extend this system by devising a way for a client to locate a particular service by making a DNS query. For example, a Windows 2000 or XP client can query DNS servers for the location of a domain controller. This makes it much easier for both the client and the administrator to manage and distribute logon traffic in large-scale networks. For this approach to work, Microsoft had to have some way to register the presence of a server or really a TCP IP protocol in DNS, but none of the RR types you've read about so far offer any way to do so. Enter the service SRV record. SRV records tie together the location of a service like a domain controller with information about how to contact the service. Think of a host record. It ties a name to an IP address. The MX record extends the concept by adding another parameter, the preference. SRV records take it even further by providing 7 items of information. Let's look at an example to help clarify this powerful concept. LDAP tcp.chalice.net SRV10 100.389 hsv.chalice.net LDAP tcp.chalice.net SRV 20 100.389 mysy chalice.net. The first field, LDAP.tcp.chalice.net, is actually a composite. It contains a service name LDAP for LDAP or Kerberos for Kerberos, a transport protocol TCP or UDP, and the domain name for which the service is offered. Thus, LDAP.tcp.chalice.net indicates that this SRV record is advertising an LDAP server for the chalice.net domain. The next field is just the record SRV in this case. The two numbers following are the priority and the weight. The priority field specifies a preference just as the preference field in an MX record does. The SRV record with the lowest priority will be used first. The weight is a little different. Service records with equal priority will be chosen according to their weight. Consider the case of 3 SRV records, a priority 0 and a weight 100. That tells the DNS server to answer queries by picking one of the 3 at random because they have equal weight. If one record has a weight of 50 instead of 100, it would be chosen twice as often as earlier of the other records. The next field is the number of the port on which the service is offered, 389 for LDAP and 88 for Kerberos. The final entry in the record defines the DNS name of the server that offers the service, in this case HSV chalice.net and mysy.chalice.net. You'll read later about how these records are actually used in DNS queries, and for now it's enough to understand that they exist. Zone database files. Let's assume that you're not using an ADI zone. The only reason we make that assumption is to illustrate where the zone database files live on a non-ADI server. As it turns out, you can specify names for some but not all of these files when you install DNS on your Windows Server 2003 computer. The specific zone database files are discussed in the following sections. The domain name file. Each domain has a forward lookup zone on your server, will have its own database file. For example, when you create a new zone named Chalice.net on a Windows Server 2003 DNS server, you'll end up with a new file name called chalice.net.dns in the system's DNS directory, system root /system32 /DNS. The file is pretty much empty when you create the zone. It contains only an SOA record for the domain and one NS record listing the name of the server you just created. As you add new A records to the domain, they're stored in this file. The reverse lookup file. This database file holds information on a single reverse lookup zone. These zones are usually named after the IP address range they cover. For example, a reverse lookup zone can handle queries for the 172.30.1. block will be named 130.172.inaddr.arpa. Notice that the network address is reserved. Remember that the reverse lookup database allows a resolver to provide an IP address and request a matching host name. It looks like the domain database file. For example, it has SOA and name server records, but instead of A records, it has one PTR record for each host designated in the reverse lookup zone. DNS reverse lookup is frequently used as a sort of backdoor authentication method. For example, most modern mail servers can be configured to refuse incoming mail from servers whose IP address can't be resolved with a reverse lookup. This prevents people with real IP addresses but fake DNS names from using those mail servers, thus preventing spam. Reverse lookups are also valuable for troubleshooting name resolution problems because you can always find the IP address of a machine even if you're not sure what its domain name is supposed to be. The cache file. The cache file contains host information needed to resolve names outside the authoritative domains. In short, it holds a list of the names and addresses of root name servers. If your DNS server will be able to connect to the internet, you can leave this file alone. If not, you can edit it so that it lists the authoritative root for your private network. So I'm going to leave it here this evening for this live stream. Thanks for listening and have a nice evening.